the entire universe will be aware of this one explosion. It's a star that is on the verge of death. Betelgeuse, one of the most well-known stars in the night sky. It has long captivated the imagination of astronomers and stargazers alike. Its distinct reddish hue and massive size make it a key feature of the constellation Orion, visible to the naked eye from Earth. Recently, however, Betelgeuse has taken center stage for a reason that has left the scientific community abuzz. A sudden and dramatic 250% increase in its brightness detected by the James Webb Space Telescope, JWST. This has raised fascinating questions about the star's immediate behavior and long-term fate. Before we start, hit the like and subscribe buttons for more exclusive news. Betelgeuse is a red supergiant, a star that has reached the final stages of its stellar evolution. Located roughly 642.5 light-years away from Earth, it is one of the largest and brightest stars in our galaxy. About 700 times the diameter of the Sun and more than 10,000 times as luminous. This type of star is notorious for its instability as it nears the end of its life, and Betelgeuse has provided ample proof of this through its irregular dimming and brightening cycles. Nevertheless, this latest and particularly intense surge in brightness is unlike anything astronomers have recorded before, making it a significant event for the field of astrophysics. The James Webb Space Telescope, designed to study the universe with unprecedented precision, played a critical role in detecting this sudden change. Using its infrared capabilities, JWST has been able to peer through the vast layers of dust and gas surrounding Betelgeuse, offering scientists a clearer view of the star's surface and its surrounding environment. What the telescope found was nothing short of extraordinary. Betelgeuse's brightness had increased by a staggering 250% in a matter of weeks, a rapid and unexpected shift that immediately suggested something unusual was happening within the star. The implications of this sudden increase in brightness are profound. For one, Betelgeuse has long been a candidate for a supernova event, a massive explosion that occurs when a supergiant star exhausts its nuclear fuel. While Betelgeuse is expected to go supernova sometime in the next 100,000 years, this new burst of energy raises the question of whether that moment might be approaching sooner than anticipated. The star's fluctuating behavior in recent years, combined with this latest surge, suggests it could be entering a more unstable phase, one that may precede a final catastrophic explosion. A supernova event within our galaxy would be an astronomical spectacle unlike any seen in modern human history. If Betelgeuse were to explode, it would be visible from Earth even during the day, outshining the full moon for several weeks. However, despite the star's proximity, such an event would pose no direct threat to life on Earth due to the vast distance separating us. Instead, it would offer a once-in-a-lifetime opportunity for scientists to observe a supernova in real time, gaining invaluable insights into the processes that govern the death of massive stars. The sudden brightening of Betelgeuse also prompts new questions about the inner workings of red supergiants. These stars are notoriously difficult to predict, as their vast size and complex internal dynamics create turbulent conditions that challenge even the most sophisticated models. Betelgeuse, in particular, has confounded astronomers for years with its erratic light patterns. Understanding why its brightness has suddenly surged by 250% could offer new clues about the life cycles of red supergiants and the processes that drive their fluctuations. One theory that has emerged in response to this event is that Betelgeuse may have experienced a massive convective cell or hot bubble of gas rising from its core to its surface. Such convective events are common in supergiant stars and can cause significant changes in brightness as material is ejected from the star's outer layers. If Betelgeuse did indeed experience such a convective event, it could explain the rapid increase in its luminosity, as the hot gas released into space would temporarily brighten the star. Another possibility is that Betelgeuse has shed a significant amount of mass in the form of a stellar eruption, creating a cloud of dust and gas that may be interacting with the star's light. In 2019, Betelgeuse experienced a mysterious dimming event, which some scientists believe was caused by a large mass of dust obscuring part of the star. This latest brightening could be a reversal of that process, with new material being ejected and illuminated by the star's intense light. Yet another intriguing hypothesis is that the star's magnetic field may be playing a role in these changes. Betelgeuse's magnetic activity is not fully understood, but recent studies suggest it may have a complex and dynamic magnetic field that could influence its brightness. Changes in the magnetic field could alter the way energy is transported through the star, leading to rapid fluctuations in its luminosity. If this is the case, the current surge in brightness could be tied to a shift in Betelgeuse's magnetic activity, which might provide a new avenue of exploration for scientists studying stellar magnetism. As astronomers continue to monitor Betelgeuse, The sudden increase in brightness also raises questions about the role that stellar mass loss plays in the evolution of supergiant stars. Red supergiants like Betelgeuse lose mass at a prodigious rate, shedding large amounts of gas and dust into space. This process is thought to play a key role in the final stages of a star's life, as the loss of mass can affect the star's structure and stability. If Betelgeuse is indeed losing mass at an accelerated rate, this could signal that it is approaching a critical point in its life cycle, one that may lead to further instability and eventually a supernova. The timing of this event also comes at a crucial moment for astrophysics. As the James Webb Space Telescope continues to revolutionize our understanding of the universe, JWST's ability to detect infrared light has opened up new possibilities for studying the most distant and obscure objects in space. Betelgeuse's sudden brightening has provided an ideal target for its cutting-edge instruments. By capturing detailed images and data of Betelgeuse in its current state, JWST is offering scientists an unprecedented opportunity to study the complex behavior of a red supergiant on the brink of transformation. Despite the excitement surrounding Betelgeuse's potential future as a supernova, it is important to note that this latest increase in brightness does not necessarily mean an explosion is imminent. Red supergiants are known for their unpredictable behavior, and Betelgeuse may simply be going through another of its many phases of instability. However, the sheer magnitude of the change, an increase of 250% in brightness, is extraordinary and suggests that something significant is happening within the star. As astronomers work to unravel the mystery of Betelgeuse's sudden brightening, the event highlights the dynamic and often chaotic nature of stellar evolution. Stars like Betelgeuse, which have reached the final stages of their lives, are subject to a host of internal and external forces that can dramatically alter their appearance and behavior. Understanding these processes is essential not only for predicting the future of stars like Betelgeuse but also for gaining insights into the broader mechanisms that govern the life and death of stars across the universe. The sudden increase in Betelgeuse's brightness also serves as a reminder of the vast and often unpredictable forces at play in the cosmos. Stars are not static objects but rather living, dynamic systems that change and evolve over time. Betelgeuse, with its rapid fluctuations in brightness, provides a window into the complex and often violent processes that drive stellar evolution. As scientists continue to study this remarkable star, they are likely to uncover new insights into the forces that shape the universe. One of the most exciting aspects of this discovery is the potential for future observations. Betelgeuse is now being closely monitored by a variety of telescopes and instruments, including JWST as well as ground-based observatories. These observations will allow scientists to track the star's behavior in real time, providing a wealth of data that could help to explain the underlying causes of its sudden brightening. Over the coming months and years, astronomers will be watching closely to see if Betelgeuse's brightness continues to fluctuate or if it returns to its previous levels. The implications of this event extend beyond Betelgeuse itself. Red supergiants are a common type of star in the universe, and studying Betelgeuse's behavior could provide valuable insights into the life cycles of other massive stars. By understanding the processes that drive the fluctuations in Betelgeuse's brightness, scientists can apply these lessons to other stars, helping to build a more complete picture of how supergiants evolve and die. This, in turn, could shed light on the formation of supernovae, black holes, and other exotic objects that play a critical role in the universe's evolution. In addition to its scientific significance, the sudden brightening of Betelgeuse has captured the public's imagination, reminding us of the wonders of the universe and the mysteries that still remain to be solved. Betelgeuse has long been a star of legend and mythology, associated with the figure of the hunter Orion in various cultures. Its dramatic and unpredictable behavior only adds to its mystique, making it a star that continues to inspire wonder and curiosity in both scientists and the general public. The sudden increase in Betelgeuse's brightness is not only a stellar anomaly but also a testament to the profound and evolving nature of the cosmos. The star, once considered predictable in its general patterns of variability, has now presented astronomers with a stark reminder of how little is truly understood about the life cycles of massive stars. This 250% surge in luminosity, a change detected by the James Webb Space Telescope (JWST), has sent shockwaves through the scientific community, raising fresh questions about the internal mechanics of such colossal celestial bodies and their eventual fate. To delve deeper into the implications of this event, it's important to explore not only the scientific and technical details but also the broader cosmic and philosophical consequences of this unexpected brightness. Betelgeuse, a red supergiant at the terminal stage of its life, has always been a fascinating object of study due to its peculiar and irregular behavior. Yet this most recent development, the unprecedented increase in brightness, has forced scientists to reconsider established models of stellar evolution, particularly for supergiants. The sudden surge raises fundamental questions about the forces at work inside Betelgeuse that could cause such a dramatic shift. As with many large celestial bodies, Betelgeuse is governed by complex interactions between gravity, fusion processes, and magnetic fields, each of which could be contributing to its recent outburst of luminosity. One area where this event may provide critical insights is in the study of stellar fusion. At the heart of every star, including Betelgeuse, nuclear fusion reactions generate energy that counterbalances the force of gravity pulling the star inward. In a supergiant like Betelgeuse, these reactions are more complex than in smaller stars like our Sun because the core's extreme temperatures and pressures can lead to the fusion of heavier elements beyond hydrogen and helium. During the final stages of a red supergiant's life, these fusion processes become increasingly unstable as the star struggles to fuse heavier and heavier elements until it can no longer sustain the energy required to counteract gravity. The 250% increase in Betelgeuse's brightness could indicate a dramatic shift in its fusion processes, possibly involving the fusion of heavier elements in the star's core. As it runs out of fuel, the core contracts, and the outer layers may react violently to changes in the star's internal structure. This could result in large-scale ejections of material, which could momentarily cause the star to brighten significantly. In this context, the recent brightening could be a prelude to more violent convulsions within Betelgeuse, bringing it one step closer to its inevitable demise as a supernova. However, this increase in brightness is not merely a sign of impending doom. It also sheds light on the often overlooked phenomenon of stellar mass loss in supergiant stars. Betelgeuse, like many other stars in this phase, has been gradually losing mass over time through stellar winds and outbursts. These ejections of gas and dust form intricate clouds surrounding the star, which can obscure its light or cause it to shine more brightly, depending on how the material interacts with light emitted from the star. This process is crucial to understanding the life cycle of supergiants, as mass loss directly impacts their structure, stability, and eventual supernova explosion. The sudden increase in brightness could be connected to an especially large ejection of material, which may have exposed previously hidden parts of the star's hotter interior. Beyond the mechanics of fusion and mass loss, the JWST detection of Betelgeuse's increased brightness also opens new avenues for studying the star's magnetic field. While not as well understood as the magnetic fields of smaller stars like the Sun, red supergiants are known to possess complex magnetic structures that can have significant effects on their behavior. Changes in the magnetic field can alter the way energy is transported throughout the star, potentially leading to sudden fluctuations in brightness. Betelgeuse's magnetic activity could be undergoing shifts, which might provide an alternative explanation for its recent outburst of luminosity. The sudden increase in brightness also brings into sharp focus the role of convection in massive stars like Betelgeuse. In red supergiants, convection, where hot material rises from the star's core and cooler material sinks, is a dominant mechanism for transporting energy. Convection can lead to the formation of massive cells or plumes on the surface of the star, which can cause dramatic shifts in brightness if one of these cells reaches the surface and ejects material. Given the scale of Betelgeuse, these convective processes operate on a level that is difficult to fully comprehend. If a particularly large convective plume has formed within the star, it could be driving the sudden increase in brightness observed by the JWST. Such phenomena are not just theoretical considerations. In fact, Betelgeuse has displayed erratic behavior before, notably in the mysterious dimming event of 2019 to 2020. At that time, astronomers debated whether the dimming was caused by internal changes within the star or by an external dust cloud partially obscuring its light. This new brightening event, however, is the opposite, an unexpected surge in luminosity that has again baffled scientists. The fact that Betelgeuse has undergone such drastic changes in such a short period of time suggests that we may be witnessing the final stages of a red supergiant's life in real time, an unprecedented opportunity to observe these massive stars in action. As the star continues to be monitored, particularly by JWST with its unparalleled ability to capture infrared wavelengths, scientists will gain more precise data on the processes occurring within and around Betelgeuse. The telescope's ability to peer through the clouds of gas and dust surrounding the star provides a clearer view of the mechanisms driving these sudden changes in brightness. With JWST, astronomers are not only able to track Betelgeuse's light variations but also study the composition and structure of the material it ejects, shedding light on the star's mass loss and internal dynamics. While the scientific ramifications of Betelgeuse's sudden brightening are profound, the cultural and historical significance of the star cannot be overlooked. Betelgeuse has long been an object of fascination for humans, appearing in myths, legends, and cultural narratives across the world. Its prominent position in the constellation Orion has made it a fixture in the night sky for millennia, and its eventual fate as a supernova could leave an indelible mark on the history of human astronomy. When Betelgeuse finally does explode, it will be one of the most dramatic events in recorded astronomical history. Although the star's proximity to Earth, around 642.5 light-years, ensures that we won't face any direct danger, the brightness of the supernova will be extraordinary. For weeks, Betelgeuse's supernova would be visible during the day and could outshine the full moon at night. Such an event would be a remarkable spectacle, perhaps even comparable to the supernova that was observed in 1054 AD, which led to the formation of the Crab Nebula. That explosion was so bright it was visible during the day for several weeks, and its remnants are still studied today. A similar explosion from Betelgeuse could provide astronomers with a once-in-a-lifetime opportunity to observe the death of a massive star up close. While the sudden brightening does not necessarily mean a supernova is imminent, it does suggest that Betelgeuse is entering a more active and unpredictable phase. Scientists are cautious about predicting exactly when the star will explode, as the timescales involved in stellar evolution are vast compared to human lifespans. However, every new observation, such as this latest brightness surge, brings us one step closer to understanding when and how Betelgeuse will meet its spectacular end. The importance of studying events like this lies not just in understanding Betelgeuse itself, but in unlocking the broader mysteries of stellar evolution. Red supergiants like Betelgeuse are rare, and even rarer still is the opportunity to study one in such detail. By observing the behavior of Betelgeuse and its eventual supernova, scientists will gain insights into the life cycles of massive stars, the formation of elements, and the processes that lead to the creation of black holes or neutron stars. These processes are crucial to the formation and evolution of galaxies, including our own Milky Way. The sudden increase in Betelgeuse's brightness also has implications for our understanding of the interstellar medium, the vast diffuse clouds of gas and dust that fill the space between stars. When a supergiant like Betelgeuse loses mass, it contributes to the enrichment of the interstellar medium with heavy elements that can later form new stars and planets. The material ejected from Betelgeuse during its final stages will eventually mix with the interstellar medium, seeding the galaxy with the raw materials needed for the next generation of stars. In this way, Betelgeuse's death will not mark an end but rather a beginning, as the material it releases will contribute to the ongoing cycle of stellar birth and death in the cosmos. This latest surge in brightness also underscores the importance of space-based observatories like JWST. Ground-based telescopes have provided invaluable data on Betelgeuse for decades, but they are limited by Earth's atmosphere, which can obscure certain wavelengths of light. The JWST, orbiting far above Earth's atmosphere, can capture a much broader range of wavelengths, including infrared light, which is essential for studying objects like Betelgeuse that are often shrouded in dust. The JWST's ability to detect subtle changes in Betelgeuse's brightness and spectrum offers an unprecedented opportunity to study this star in detail, providing clues about its future behavior and eventual fate. The dramatic surge in Betelgeuse's brightness detected by the James Webb Space Telescope, JWST, continues to unravel layers of mystery about the behavior of red supergiants in their final evolutionary phases. As one of the most scrutinized stars in the universe, this 250% increase in brightness has amplified scientific interest in Betelgeuse and its complex, volatile nature. Beyond the previously explored internal mechanisms such as fusion, mass loss, convection, and magnetic fields, this event invites a broader exploration of astrophysical phenomena, including stellar variability, the surrounding interstellar environment, and the broader implications for understanding cosmic evolution. Betelgeuse's unexpected luminosity surge emphasizes the intricate nature of stellar variability. Stars undergo cycles of variability for numerous reasons, ranging from internal processes to interactions with external environments. However, the magnitude and speed of Betelgeuse's change in brightness make this event a particularly unusual and urgent case study. Typically, variability in stars follows relatively predictable patterns governed by factors such as pulsations or binary interactions. Red supergiants like Betelgeuse, however, are more erratic due to their immense size and the dynamic conditions within their outer layers. This variability often defies simple categorization, as seen in Betelgeuse's case, where an unpredictable surge in brightness presents new challenges to existing models of stellar evolution. To understand Betelgeuse's sudden brightening, scientists must also consider the role of pulsations, another form of stellar variability common among supergiants. Pulsating stars undergo periodic expansions and contractions driven by imbalances between gravitational forces and the outward pressure generated by fusion in their cores. These pulsations can lead to observable changes in a star's brightness, temperature, and size. In the case of Betelgeuse, pulsations may be contributing to its recent luminosity surge. Some red supergiants experience long secondary periods where significant changes in brightness occur over extended time scales, possibly driven by large-scale pulsations that alter the star's structure. If Betelgeuse is entering such a period, the 250% increase in brightness could be just one phase in a longer, more complex cycle of variability. Further, the JWST discovery brings to light the interaction between Betelgeuse and its surrounding interstellar environment. Betelgeuse has been shedding material for centuries, forming a vast shell of gas and dust around it. This circumstellar environment, composed of elements ejected during the star's life, plays a significant role in how Betelgeuse's light is perceived from Earth. Dust, in particular, can absorb and re-emit light, which can either dim the star or, as may be happening now, amplify its apparent brightness depending on how this material interacts with the star's radiation. Betelgeuse's brightening may result in part from changes in the distribution of this circumstellar dust, which could be reflecting more of the star's light toward Earth or allowing more of it to pass through. The material ejected from Betelgeuse also serves as a laboratory for studying the life cycles of massive stars. As the star sheds its outer layers, it contributes to the surrounding interstellar medium, enriching the galaxy with heavy elements. This process, known as stellar nucleosynthesis, is responsible for producing many of the elements found in planets and life forms, including carbon, oxygen, and iron. Betelgeuse's current activity, including the release of material that may be causing the brightness surge, is thus part of a much larger cosmic story, the continuous recycling of matter in the universe. Stars like Betelgeuse act as cosmic forges, producing and distributing the elements that will one day form new stars, planets, and potentially life. This leads to another fascinating avenue of inquiry prompted by the brightness increase: how this material will affect the future evolution of Betelgeuse. As the star sheds mass, its internal balance of forces is altered. This mass loss can destabilize the star, potentially accelerating its progression toward a supernova explosion. The amount and rate of mass loss could provide critical clues about how close Betelgeuse is to the end of its life. Some astrophysicists believe that red supergiants like Betelgeuse undergo periodic outbursts that expel vast amounts of material in the years leading up to a supernova. If this is the case, the current surge in brightness may be a precursor to an even more dramatic event in the near future. Looking beyond Betelgeuse's immediate behavior, this event also has significant implications for our understanding of stellar evolution in general. Red supergiants are among the most massive and luminous stars in the universe, but their final stages of evolution remain poorly understood. The sudden changes in Betelgeuse's brightness highlight the need for more comprehensive models of how these stars behave in their last stages before exploding as supernovae. These models not only help astronomers predict when and how supernovae will occur but also shed light on the processes that govern the formation of neutron stars and black holes, the remnants left behind after a supernova explosion. One area that has been particularly challenging for scientists is understanding the exact triggers for supernova explosions in red supergiants. Betelgeuse, being relatively close to Earth, offers a unique opportunity to study this phenomenon up close. If its current increase in brightness is indeed related to its impending explosion, astronomers may have the chance to observe the lead-up to a supernova in unprecedented detail. This could provide critical data on how the internal structure of red supergiants changes in the final moments before a supernova, helping to refine theories about the mechanisms that drive these cataclysmic events. Betelgeuse's activity may also offer insights into the mysterious phenomenon of supernova imposters, events where stars brighten dramatically but do not end in a true supernova. These imposters can sometimes mimic the behavior of stars about to explode, but instead of a full-blown supernova, the star returns to a more stable state after ejecting some of its outer layers. It is possible that Betelgeuse's recent brightening could be an imposter event, a temporary outburst of energy that mimics the early stages of a supernova without leading to the star's immediate destruction. If so, this would provide valuable data on a phenomenon that remains poorly understood. In addition to its role in stellar evolution, Betelgeuse's brightening also has implications for our understanding of the broader cosmic environment. Supernovae are critical drivers of galactic evolution, as they release vast amounts of energy and matter into space, triggering the formation of new stars and reshaping the structure of galaxies. If Betelgeuse is indeed nearing a supernova, the explosion could have far-reaching effects on its local galactic environment. The shock wave from the supernova would sweep through the surrounding gas and dust, compressing it and potentially igniting the formation of new stars. This process, known as triggered star formation, could lead to the birth of a new generation of stars in the Orion constellation, where Betelgeuse resides. Moreover, Betelgeuse's supernova could provide an opportunity to study cosmic rays, high-energy particles that travel through space at nearly the speed of light. Supernovae are one of the primary sources of cosmic rays, which are thought to originate from the acceleration of particles by the shock waves produced during the explosion. If Betelgeuse were to go supernova, scientists would have the chance to study the production of cosmic rays up close, potentially answering long-standing questions about their origin and behavior. The event also underscores the importance of multi-wavelength astronomy in studying stars like Betelgeuse. While the JWST's infrared capabilities have been instrumental in detecting the recent changes in Betelgeuse's brightness, other wavelengths of light, such as X-rays, ultraviolet and radio waves, will also be crucial for understanding the full picture. Each wavelength reveals different aspects of a star's behavior, from the high-energy processes occurring in its core to the cooler, more diffuse material in its outer layers. Coordinating observations across multiple wavelengths will allow scientists to build a more complete understanding of what is happening inside and around Betelgeuse as it undergoes this dramatic transformation. The sudden increase in Betelgeuse's brightness has also sparked renewed interest in its role within the larger field of stellar astrophysics. Red supergiants like Betelgeuse are rare but extremely important for understanding the life cycles of massive stars. Their size, luminosity, and short lifespans make them key players in the evolution of galaxies. Studying these stars provides insights not only into how individual stars evolve but also into the processes that shape entire galaxies. Betelgeuse, as one of the nearest red supergiants to Earth, serves as a critical test case for theories about the life and death of massive stars. The event has also reignited public fascination with the night sky. Betelgeuse has long been one of the most recognizable stars in the heavens, thanks to its position in the constellation Orion and its distinctive red color. The recent news of its brightening has captured the imagination of stargazers and the general public alike, sparking discussions about what might happen next. This renewed interest in Betelgeuse highlights the enduring human fascination with the cosmos and our desire to understand the forces that govern the universe. From an observational standpoint, the sudden brightening of Betelgeuse has prompted astronomers to prepare for what could be one of the most significant astronomical events of the century. Ground-based observatories and space telescopes alike are now focused on monitoring the star, collecting as much data as possible in anticipation of further changes. This includes not only studying Betelgeuse's light output but also tracking any shifts in its temperature, size, and chemical composition. Such data will be invaluable for piecing together the puzzle of what is happening inside the star and predicting what might come next. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, are you excited about the implications of this discovery? We want to hear from you. Thank you for watching and see you next time.